Hello everyone. Welcome to the video lecture series of data structure. Today we are going to learn about the infix to postfix with parenthesized expression conversion by using tabulation method. And we're going to learn about the algorithm for that. Hi, this is Janisha, your instructor. So let's begin to convert your infix to postfix expression. Here I'm going to show the precedence table again. Okay, this is just for your revision work that how the precedence tables look like for the infix to postfix with parenthesized expression. We already know that plus minus division star dollar arrow caret abcd opening bracket and closing bracket all are there in the symbols. Each and every symbol has a different precedence inside the stack and outside the stack. In inside the stack, students, we have like 1 2 3 4. When we talk about the exponential operator, it becomes 5 and then 6 over there, then 7 8 9 0 0 dash. This is how your precedence tables look like. Rank of the operators are -1 and operands is +1. There is no rank for the opening bracket and closing bracket. The opening bracket precedence is always higher when it is in character scan column, but when it is goes inside the stack, it becomes 0. The closing bracket precedence is 0 in character scan column. There is no precedence exists when it goes inside the stack because it never goes inside the stack when we talk about the closing bracket. So here it is. The basic rules, basic things are there that when we go from plus minus to ABCD, the precedence is increasing. And here again, the plus minus, division star and dollar arrow caret all have different precedence in inside and outside the stack. What points and conditions are there? Condition is very much simple. We already know that if f of next is less than g of s of top. Here g represents the inside stack precedence and f represents the outside the stack precedence. Fine. If the condition satisfies, then you just need to perform the pop operation, else do the push. Next we have the rules. First we need to initialize the stack with the opening bracket. Second one, you need to append the closing one at your infix string. The third one, that the top element of the stack is the greater than the next value, then you just need to perform the pop operation. Fourth one, else perform the push. And the fifth one, when you found the closing bracket in character scan column, then just remove all the elements from the stack until unless you will get the first opening one. That closing, that opening get cancelled out together. All elements will be popped out, and that is your final answer. Okay, so let's look at the algorithm first. So infix to postfix with parenthesized algorithm. First, what we need to do, students, we just need to initialize our stack with the opening one. So that the thing you already know how you can read in without parenthesized method. What we did, we just write like this: initialize the stack, then top arrow 1 and as of top arrow hash. Same thing you're gonna do over here, like first the top arrow 1 and as of top arrow opening bracket, because we need to initialize with the opening bracket, right? Now what next? Next, when we talk about the reverse polish and the rank, reverse polish initialized with the null and rank must be 0. So here it is my first string which we have. Now try to take the next input character, students, that is next arrow, next character of infix. These all steps are very much similar of the previous algorithm. Now the next, the infix string is a plus opening bracket b minus c closing 1 division d. So here, students, we first get in the next, that is a, okay, whatever we get, that is a. So in the next, students, we have a. So translate starting the infix expression into the postfix. Repeat these steps until and unless you will get next is not equal to null. See, in the previous one we write like this: repeat the steps until you get next is not equal to hash, because our string is appended by hash. But here it's not like that. Although our string is appended by the closing one, but that closing one and opening one both get cancelled out together. How? That we will learn in this algorithm in step number 7. So how it will be done? Let's see. So this process, this loop is continued from step number 4, 5, 6 and 7. 4 steps are there. Now what about the step number 5? See. So step number 5 is remove all symbols from the stack. First, we need to check whether my top is less than 1. See, when starting the removing, before removing the symbol, just check it out whether the stack is emptied or not. If is that so, it means you have some values. See, the stack becomes empty. That means there is some mistake over there. Okay. So if the top is less than 1, then expression becomes invalid. Then you need to write exit. Else, start, repeat while, put the condition over here. F of next is less than g of s of top. So what to do? All steps are common, students. Okay. So first we just need to apply the pop operation, store the value in temp, then concat the value with the reverse polish, then check out the rank, like rank arrow, rank plus r of temp, and then if rank is less than 1, then we need to write invalid rank exit. So how? See, this is my character stack, new reverse polish and rank. So this is my opening bracket. The reverse polish we have the null and the rank we have the 0. Next students we have the A. A will be pushed inside the stack. Next we have the plus. So see, A will pop down from the stack. Why? Because A is in next and the g of s of top is A. So obviously plus and A. Plus is in next, g of s of top is A. Both gets compared together and what happens? Obviously A will be popped out. Okay, store in temp, appended with the reverse polish, calculated the rank, it becomes 1. And after that, what we need to do? Push plus inside. So step number 6 is push plus inside. But wait, here the twist is there. See, after removing the temp, polish and all, the step number next we have 6. Then are they matching parentheses? Here we need to first check is the parentheses are matching. That means if the opening bracket and closing bracket are coming together. If is that so, then you first need to check if f of next is not equal to g of s of top. See, the precedence of the opening bracket inside the stack and the closing bracket outside the stack both are similar, both are 0. So what you need to check if f of next is not equal to g of s of top, then and then you need to call push, and you just need to call pop. That means the opening bracket is go out from the stack. Okay. So this is the step number 6. If the situation goes like this, if the closing bracket comes over there, see, check out over here. We have the closing bracket in character scan column. Okay, that means next, then stack in the opening bracket plus opening bracket minus C. Now let me trace this algorithm for you. First, check out the conditions. Top step number 5. What we have? We have if top less than 1. Students, is your top less than 1? No, because your top is right now pointing at C. Fine. Now, what next? If f of next is less than g of s of top. Yes, correct. F of next is closing bracket. Parenthesis is 0. The precedence is 0. Okay. Less than g of s of top. What we have at g of s of top? We have C over there. The precedence is higher than closing one. Obviously, the 0 less than g of s of top condition is satisfied. The C will be popped down. C will be popped down. It goes inside the temp, appended with your output string, and then what happens? The top is decremented. Now the top becomes minus. Top becomes minus. After removing the C, appended over the stack, calculate the rank. Now top becomes minus 1. So polish becomes ABC. Now what happens with the minus? With the minus, top is at minus. Now your next is also the closing one. Next is still closing one. You are again going the step number 5. The repeat while loop is continuously going on. Okay, now the next becomes closing. The top is at minus. Compare both of them. Minus has the higher precedence. Again, perform the top pop operation. Minus goes in temp, appended with the reverse polish string. Calculate the rank. Now, what happens? Next, students, we get opening bracket. Okay, so your condition step number 5 get false. Why? Because f of next, that means f of closing bracket and g of opening bracket both are similar. So step number 5, the condition get false down and you directly move towards the step number 6. When you are comparing both has the same precedence or not. See, if both do not have the precedence, then you just need to call push. Else what do you need to do? You just need to call pop. So your opening bracket will pop out from the stack and you directly move towards the step number 7. So the step number 7 is next character of infix. So taking the next character. So automatically the closing one is also gone, right? your opening is gone in the pop operation. And the closing one is also gone, is overwritten by the next character. So fine, you just need to repeat these steps again and again, you will get your answer. This is how you can trace your algorithm. Then finally, you just need to check step number 8, students. You just need to check whether your expression is valid or not. At the end, your top must be at 0 and rank must be 1. If it's that not so, then your expression is invalid as it's valid. So here, it's all about the infix to postfix with parenthesized algorithm. Okay, just try to take one example and trace this algorithm according to you. If you feel any doubt, then please feel free to ask me. Thank you so much.